Hello colleagues, and welcome to week 1 of SAP Cloud Platform Version Control with Git. This week we are going to focus on the basics in order to build a strong foundation for more advanced topics in weeks 2 and 3. Of the 3 big weeks of the course, this week is the easiest, but I want to encourage you to pay very close attention because there are a lot of gotchas here. When I teach this material in a classroom environment and a participant gets confused on later advanced concepts, it's normally because they misunderstood something basic that we will cover here, like distributed version control, repository awareness, which repositories are aware of each other, or the nature of a branch, what a branch is. In this unit, we're going to try to get a conceptual handle on the difference between a distributed version control system, like Git, and a centralized version control system that most developers are more accustomed to dealing with. In Unit 2 through 4, we're going to talk about and give demos of the various cloning strategies you could use with your Git repositories. You can keep both your repositories on the SAP Cloud Platform Git service and clone from there. You can start with a repository or some other Git hosting service like GitHub or Bitbucket, or you could just start development directly in the Web IDE without a remote repository and then connect it to a remote later on. And by the way, if those descriptions don't make sense to you, don't worry, they will. In Unit 5, we will discuss and demo the staging area and how Git knows which changes you want to be tracked in a new version. And in Unit 6, we're going to give a demo of stashing. In Unit 7 and 8, we're going to discuss the nuances of branches and tags. This is a concept that is simple in theory, but usually misunderstood by developers new to Git because the branch concept doesn't mean what developers often expect it to mean, and misunderstanding this will make all the later Git concepts very difficult to grasp. We will finish the week with Unit 9 with a discussion of a demo of reverting, which is Git's powerful repository undo feature that works on a commit level. So, let's dive in to this unit and discuss the nature of distributed version control. If you could only listen to or understand one lecture in all the 35 lectures or demos of this course, this is probably the most important one. It's not going to be a demo, but the concept is very important. So, as I've tried to explain the concept of distributed version control to people, the most helpful way I've found to explain it is to think of distributed version control as the next stage in the evolution of version control systems. So let's take a broad conceptual look at the history of version control systems. The stages I've outlined here are physical drafts, electronic file-based version control, local access version control, server-based version control, and finally, distributed version control. First, it's worth noting that the idea of version control is quite old, much older than computers themselves. Now, I live near the city of Philadelphia, which, as American cities go, is considered to be quite an historic town. Not long ago, my wife and I took our children to see some of the historic educational sites in the area, and I noticed the document you see here in this slide framed on the wall. It's a copy of the American Declaration of Independence, but what makes it interesting for our purposes is that it's not the final draft. What you see here is an early draft penned by the author, Thomas Jefferson, and you can, if you look closely at it, you can see the code review edits done directly on the document, written by the code reviewers, who in this case were Benjamin Franklin and John Adams. So here's the idea, which is at least hundreds but probably thousands of years old. By keeping track of multiple versions of text, you can improve the quality over time without ever risking losing your work. That's what I call the first stage in the evolution of version control. Now, with the advent of computers, you had an immediate improvement. Instead of having all these paper copies you had to keep track of, you could store all versions right there on a computer. At right, you have what you'd often see on my computer when I was in high school. This is before word processors had all the editing and review features built in. An early draft of an English paper I had to write would maybe have the name of the paper. Then I would make some edits, and I would save it to a different file, and I'd add the word new to the file. And I'd make some more edits, and I'd add the words really new or something like that. And I'd get more and more, and I'd have to describe the newer and newer versions in the file name. It wasn't much more efficient than keeping physical drafts. It was about the same efficiency as keeping physical drafts, but it was more compact and could save a lot of space. So with computers, you basically have moving version control to a file system. Of course, as people started programming, developers quickly decided that it wasn't very efficient to have all of those files laying around. In 1972, Bell Labs developer Mark Rochkind created SCCS, the Source Code Control System. Now, instead of having multiple files lying around with different versions, for each file you wanted to track, you could have the illusion of just one file. Anytime you wanted to make a change to the file, you could just chuck the file out of a version database, also known as a repository, and when you finished making your changes, you would check it back in. Every time you did that, it would make a new version. The beauty was that the developer didn't have to explicitly track all the file versions that were out there. This version database, this repository, gave the illusion of editing a single set of files while tracking all the changes automatically. I think it's a clear testament to how fast technology has developed that we're no longer in ancient history at this point. Mark Rochkind is still active, and he has fairly recent books on programming still sold and read today. And if you want, you can go to his website and see what he's been up to lately. Of course, software is very often developed by teams, not individuals. So the obvious next stage was to stick the version control system on a server so that everyone on the team could access that server from the machine. That way, developers could check in and out files and collaborate on a project. So in this model, it's very similar to the previous model, but you have a single repository that all developers can access. Of course, this has certain limitations. For example, if you're talking about a single version of a single file, only one developer could work on it at a time. Now, good centralized version control systems provide some sophisticated ways to get around this, like creating multiple branches of the code, for example. But basically, all developers are sharing the same version database, the same repository of the code, and they have to coordinate their efforts to manage the code together. So in my experience, this stage of the evolution of version control is what most people think of as version control. This is what most developers are used to if they haven't used Git before. If you've used CVS, or if you've used Subversion, or Rational Clear Case, or if you've just done ABAP development on NetWeaver with the team, then you are accustomed to thinking of version control in terms of centralized version control. Now, the last and final stage is the whole point of this lecture. Now, as I mentioned in the last lecture, the open source development model, which in the case of Linux involved more than 10,000 developers, required both a new level of sophistication and also the flexibility to support independence and even projects splitting off into completely different directions. So in the last stage of version control evolution, you have this new big idea. What if, instead of everyone having access to one source code repository, every single developer gets their own individual source code repository, their own version database? If you've never worked with distributed version control before, that idea can be a little mind-blowing. Experienced distributed version control developers hate it when I describe it this way, but if you've never used anything but a centralized version control system before, you can almost think of it as each developer having their own separate centralized version control system. Now, if you don't like that analogy, just forget it. But think about what this means and what it changes. Everybody's got their own version database. First, it means that if a developer chooses to, they could, in theory, just create many versions and branches on their own local version database, their own repository, for a really long time without ever communicating with any of the other version databases, the other repositories. That's not recommended, but it's possible. Of course, at some point, the developers will need to coordinate their work. Okay, that means what's required in this scenario is that if you have two completely different kinds of commands to deal with repositories. You got two different kinds of commands. The first kind of command you would use to manipulate your own local repository. So on your own personal code database, your own repository, you have the ability to create new versions and create new branches and things like that. But then there's a separate set of commands to get your entire repository in sync with the repository of other developers. Now that sounds really complex. So you got two sets of commands. You've got commands to manage the version database of your own, and you've got commands to manage the communication between the version databases and get them in sync. Okay, that sounds really complex, but we're going to see that because of Git's slick design, it's actually not that hard. Now, I've found that the people who struggle the most with Git often struggle because they are trying to think of version control in terms of centralized version control, in terms of a single repository shared by the entire team. So it's really important when you're working with Git to always be asking, right now this command I'm using, am I just changing my own local repository, or am I affecting other repositories as well? So if there's just one Git concept that you wanted to understand to set you up to understand other things in Git, I think this is the most foundational one. Okay, look at the picture here on this slide. It shows a group of developers who has a slightly unorthodox setup using Git, but it illustrates the point well. This group has chosen to make one repository central to the entire team, and all except for one developer, if you look, is sending commands to sync his or her repository with the central one. Then you see that a few of the developers aren't just syncing their repository with the central repository, they're also syncing their repositories with each other. This is the kind of flexibility and loose organization that Git enables. It's worth mentioning here that Git is not the only distributed version control system that exists. It's just the most popular one. Mercurial is an example of another distributed version control system. There's one other cool aspect of this that makes distributed version control and Git perfect for open source development and for teams that want to reuse code. Notice that any single developer in the diagram on the right could take their own repository and they could make it the new central repository of a new project. It's really, really easy to spin off new development projects off of old ones with distributed version control. But, as Uncle Ben Parker said in the original Spider-Man comics, with great power comes great responsibility. All this flexibility and power that is provided by a distributed version control system like Git means that sometimes you have to be more intentional in coordinating your development efforts with others on your team. So, that's my broad overview of the history of version control. I hope you found it helpful to understand the difference between traditional centralized version control systems and distributed version control systems. Now, I've added a few links at the end of these slides if you want to learn more about the history of version control. Now, join me in the next session, Unit 2, where we're going to move out of the conceptual territory and we're going to get really practical as we begin to cover various cloning strategies.